we will talk about, you will see in my slide deck, and more specifically, if you already wanted to look at that, have a look at exercise number 12. And that is, in fact, the last one for today. So if you don't want to sit in until tomorrow, this is kind of like the two commands that you would have to work with. So if you were to create infrastructure that is not managed by Terraform yet, or that has been made in general, you will have to look into those two different commands. Optimally, you would have all the infrastructure managed by Terraform, but sometimes you're transitioning over to Terraform, or you made some manual changes. In those cases, it gets a little bit more complex. But the two commands that are important are import and the state command. So have a look at those. And then there's another question on managing multiple environments. For example, development, staging, and production. And you can see this is more a question in the context of a CI/CD pipeline. And I will give you some pointers on additional tools that we can bring in here, for example, how to test this. So I would say like the second question is more out of scope for the actual certification program, but I can definitely give you some additional pointers during the break when everybody else is working on these specific exercises here. So hold on a bit. We'll definitely want to build the foundation for everybody else, but I will try to answer your questions as we go along. All right, any more questions about the exam so far? If not, we'll jump in and talk about the first topic of the exam, which would be the theory behind infrastructure as code. I guess for everybody that's already using Terraform, this might be a little bit boring, but given that we're preparing for the certification program specifically, I want to make sure that we cover this as well. You will see this is not super hands-on in any kind of form with the help of Terraform. It really is just the theory behind how Terraform or what guidelines Terraform follows. All right, looks like there's no question right now, so we'll just move on and talk about infrastructure as code, also referred to IAC. So if you see IAC, this is what we're referring to here. Here we'll want to talk about the benefits of this approach and kind of like how it is implemented in more detail. So here, in fact, is a question about the exam. So let me answer that. Where is the test taken? In a test center, or is it all online? At the moment, I believe because of COVID, there's no more test center that you have to like sign up for. It's all online. So when you register for the exam, you buy the voucher, and then you would basically just pick a time and a date from the calendar, and you would simply take the test from home. All you need to have is a computer that has audio feed and a video feed. So you will actually have to enable your camera, and you will have a proctor that will look over your shoulder, so to say, and will make sure that you don't cheat. But everything else can be taken from home. Just need to clear your desk. Usually you have to show around in your room. You just want to make sure you're not cheating. But ultimately, that's pretty much it. I don't think there's even an option anymore to take the test in a test center. And I guess a lot of these certification programs actually switched over to online only. So if you compare this to other ones, like, for example, the Kubernetes exams, those are all online. They are not taken in the test center anymore. And I would say a couple of other ones probably too. All right, so let's jump into infrastructure as code. We'll simply want to build the foundation. And I'll try to go a bit quicker here so we can make it more interesting later on when we talk about Terraform specifically and how Terraform implements these concepts. So let's first define what infrastructure as code is. It's basically managing the infrastructure with the help of code. So instead of basically defining your infrastructure manually, either with the cloud provider tool, for example, if you want to create an instance here in AWS, you could, for example, create a new instance from here, from the management console. We could say launch instance, you provide and those are not managed in any kind of form. What we want to strive for is that we want to define a code for anything else that you would want to achieve when coding a program. So we really want to manage the code as software. We want to define exactly what kind of instances of EC2 we need. For example, we want to define how it is configured as part of a configuration file, and that is the approach of infrastructure as code. One nice side effect of infrastructure as code is that we can track those changes in version control. So all the configuration that we will create are usually checked into version control. We have all the tracking and the timestamps, all the commits that change over time. And therefore, we know exactly what changed and who changed it. And then with the help of the right tooling, and Terraform is one of those tools, we can make sure that whenever we provision infrastructure, is that the configuration looks exactly like what we actually have deployed on the cloud. So we want to be consistent, we want to have a repeatable process, and we want to make changes as fast and reliable as possible. So usually the workflow looks as such. We would change the configuration file, and then we would deploy those changes to the cloud with the help of Terraform. I can see there are a couple of questions here. Will the slides be available? Yes, they are already available. So if you joined a bit later, you can find the slides right here. So let me post that one. To an existing EC2 instance, for example, we want this to run in a different zone, in a different region. Then we can make those changes to the configuration file, and Terraform will be smart enough to actually make those changes accordingly. But ultimately, we're not creating any duplicates of what we have in the configuration file by just rerunning the process again. And here's just one example for each of those concepts or benefits. I just provided an example here as well to make it more relatable. For example, we have a database that was deployed with a specific port, but the port needs to change because maybe the application changed or the connection URL changed. In those cases, we can simply change the port number in the configuration file and then tell Terraform to roll out this change. This does not mean that we're going to create another database in any kind of form. It only means that we're making the change to the port. Somebody mentioned before as a question, they might have different environments, and that also means different environments on the cloud provider. For example, you might want to have a staging environment that is separate from production to try things out before you actually roll it out to end customers. And Terraform also supports this use case. And Terraform calls those workspaces. And the workspace is responsible for having dedicated configuration for a specific environment. Potentially, the environments will look slightly different, for example. In development, it might look slightly different. You might not need all the infrastructure as you need in production, but ultimately, we can make sure that environments look very similar or exactly the same. Optimally, if you look at this from the perspective of continuous delivery, for example, we want to make sure that all environments look exactly the same. And there's a good reason for it. We want to make sure that whatever we are testing in the development environment or whatever we're testing in staging will look exactly the same in production. So therefore, we will not run into any specific surprises simply because the infrastructure looks different between different environments. I already mentioned some of those environments here: development, staging, and production. Those are typical ones that you will also find in the most popular continuous delivery book. And I'm pretty sure that if you're responsible for infrastructure at your company right now, you will probably already deal with one or many of those environments. Optimally, the automation code will also look similar, if not the same. And we will learn later on in Terraform can make sure that those environments can be created consistently with the same configuration files. And just to give you again one example to make it more relatable, let's say our development environment should have a single EC2 server. But not only just in development, we want to have the same kind of configuration, say in staging, in production. Sometimes you might actually want to have different configuration depending on the environment, but that is a somewhat more advanced topic here. But if you want to make them all look the same, you definitely can. You will see that Terraform doesn't have just a canned set of features. We can reuse existing functionality that can be developed separate from Terraform core. So when I talk about Terraform core, that is pretty much the basic functionality of Terraform. You will see that we'll use plenty of reusable functionality that will help us, for example, deploy to AWS in a consistent manner, or to GCP or other environments. There's reusable functionality in the form of a provider, a module, and other concepts in Terraform that helps us have reusable functionality. And you can think of this more or less as a plugin that is available on a registry, similar to any kind of reusable functionality for IDEs or any kind of other CI/CD tools. So it works pretty similar. See, there's a minor typo here, help off code. You can see I'm going to correct things as I go along. I will actually also deploy those changes to my GitHub repo after the training, so we'll actually get the latest changes as well. So code can be shared across multiple Git repos. So if you're trying to reuse existing functionality, for example, a specific provider, then this code can be reused. But you could also say, well, we want to have a specific setup for our infrastructure internally at my company. Then we can define this as well. It doesn't really just boil down to cloud providers. It could also boil down to specific configuration that you want to apply to a set of projects. You can definitely define this with the help of Terraform. One nice side effect of the configuration files or infrastructure as code is that we're writing code. This code will be checked into version control. And this pretty much describes, at least in the form of code, how your architecture should look like. So if we say my architecture should consist of 3 EC2 instances, a database, and potentially some networking configuration, then we can definitely define this with the help of code. And this is somewhat self-documenting. So that's a nice benefit that we get here out of the box. If you have a new team member that we want to ramp up, and that person might ask, well, what are you managing right now in your infrastructure? You can simply say, well, look at your Terraform configuration. We basically have it documented there in the form of code. It describes exactly how this looks like right now in production or in all the other environments. And that is really kind of nice because we don't have to actually log into the cloud provider. We don't have to look at specific attributes of the instances that we create. And therefore, we have it all configured in a configuration file. So ultimately, we're treating our infrastructure as code, and we can read that source code We can add additional documentation to the code as well, why it was created, why it is needed, and things like that. Very good. And ultimately, and this is more important to project managers and CEOs, I guess, given that we are automating the process of creating infrastructure or managing the infrastructure, we are far more efficient. So we don't have to go in manually. We don't make mistakes as we do as humans. We simply change configuration files and then roll out those changes with the help of Terraform. So less human error when we make those changes, because there's also validation logic built into Terraform. We can even write automated tests for the configuration files. We'll actually not talk about that here in this course, but keep in mind that you can even write tests for your Terraform code. And then we can also spin up or spin down specific environments with the help of the configuration that we have checked into version control. For example, we might want to say, well, during downtimes, if people are not shopping, we don't need to necessarily have, say, 50 EC2 instances. In those during those times, we might just need 10 to handle the basic load, and therefore, this concept also helps us with saving money, because we don't really have to run those instances all the time. So here's one more example. We're cutting out human error by necessarily having to go in the user interfaces of the cloud providers. We are not spending time on making changes manually across multiple environments. So therefore, we can be more consistent and can spend more time on something that actually does matter. Okay, so let me have a look at the questions you might have had. And those are, I would say, also somewhat separate. So I'm going to answer them as more of an advanced kind of topic. They're not really necessary, I would say, for the purpose of the exam. So therefore, I'm going to answer them when everybody else works on the first exercise. But I'm happy to answer them, but they're a little bit more off topic here, I would say. So let's not derail necessarily the presentation in general, but just give me a couple of more sections on the slides, and then we'll definitely be happy to answer your questions alongside. Right, any more questions about the general theory behind infrastructure as code? I think it's probably not too hard to grasp. And as you've seen here, the benefits are really helpful. They will apply to the exam as well. And they might actually ask you questions about it as well. Okay, looks like there's no question right now. So I would say, usually I try to give a 5-minute break every hour of the presentation. So I'm not going to make this too complicated. But ultimately, I will jump into the next section, then we'll get more hands-on. For now, let's take a 5-minute break, and then we'll also